Hi, hello everyone. We'll wait for 5 minutes and then we can start, okay?
Do one thing, no, log in WhatsApp here.
Okay, I think we can start now. So, in this session, we'll be discussing about the few questions from week 8 to 11. So, in the previous session, we have discussed week 5 to 8 and then few previous year question as well. So, today also we'll do the same thing, okay? But from week 9 to 11, okay? I hope I'm audible, right?
Yes, sir.
Okay. Right. So if you see the content, it's mostly a graph theory based question. Okay. So let me share my screen and we'll see the previous year question as well and how we can approach those questions. Okay. And we'll discuss one question based on recursion part. Yeah. Is my screen visible?
Yes, sir.
Yes, sir, visible.
Okay. So you must have seen previous year questions. You can see this type of question, right? So one matrix is given to you, some pseudocode is given to you, and based on that, there are few questions, right? So let's try to discuss this type of questions here. So through this, we are going to understand the concept what we have discussed in week 9, 10, 11. Okay. So suppose any graph is given to us. So I hope everyone knows the concept of adjacency matrix. What is adjacency matrix? Yes, anyone?
That is the adjacent vertices which are connected to edges, the
Uh,
immediate edges.
yes. So for example, a graph is given to us like this. Okay. So if I want to draw adjacency matrix, let's say for example M. So you can see M be the adjacency matrix for the graph G. Okay. Then how we can draw? So first we'll try to discuss the concept and then we'll see how we can directly solve this question. Okay, without drawing the adjacency matrix, but we'll understand the concept first. So here, how many nodes we have? See, you can see 0, 1, 2, 3, 4, 5, 6. So we have 6 nodes, right? So what will be the size of matrix? Is anyone?
36. So total 36
Yeah.
elements.
So 6 by 6 matrix, right? So it will be a square matrix of 6 by 6 matrix, right? So here I'm writing it down like this. So let's say we have this 0, 1, 2, 3, 4, and 5. So here also 0, 1, 2, 3, 4, 5. So I have written down the vertices here. Now you can see these are the rows, these are the columns. Now zeroth row, zeroth column, right? So what we can say about this? So we are at this particular node 0. So from 0, can I go to a node 0?
Yes, I can, but there is no adjacency matrix. Not in one. Yeah,
No.
there is no
Yeah,
one direct. Yeah.
directly we cannot go. We don't have this self loop kind of thing, right? So we cannot go from 0 to 0. So that's why here it will be a 0 like that. Okay. What about 0 to 1? Can I go to 0 to 1 directly?
No.
No. So it will be
No.
again 0. What about 0 to 2?
Yes, this one.
Yes,
Yes.
sir, we will go.
Can go to 0 to 2. Yes. So I will mark it as 1. What about 0 to 3?
No, sir.
No, sir, no.
So here arrow is opposite, right? So this is basically we can see directed graph, and if we have this type of line, it means what? I can go from both I to J. Suppose we have I and here J. So this means what? From I to J I can go, but from J to I cannot go. But here in this case, if we have this type of line without arrow, it means what? I can go from I to J as well as J to I like this. Okay. So from 0 only I can go to 2. Okay. Not 4 and not 5. No, not 3 also, right? So all the remaining will be what? 0, this will be 0, 0, 0. So we are done with the zeroth vertices. What about the first one then? From 1 where we can go?
Only four would be one. Otherwise, would
Only four, sir.
Only 4, right? So from 1 and only I can go to 4. So rest all will be 0. So 0, 0, 0, 0. And here 1 to 4 will be 1. Rest 0. What about 2? From 2 where we can go? Can we go to 0, 1, 3, 5?
1, 3, we will go.
1 and 3 only, right? You can see the arrow here. From 2, I can go to 1 and 3. No 4 because, and no 0 and 5 as well because arrow is opposite. So 1 and 3. So 0, 1, 0, 1, 0, 0 like this. What about the third vertices? This one. What is number 3?
Only 0, sir. Only
Only
0.
0. Right? That's it. Rest all will be 0, 0, 0. We cannot go. What about the vertex 4?
Only 5.
Only 5, right? So here we can see 0, 0, 0, 0, 0, 1. What about vertex 5? Where we can go?
Only 2.
To 2 only, right? Not to other any nodes. So that's it. So 0, 0, 1, 0, 0, 0. So this is basically a adjacency matrix for a given a graph. Okay. So you can see here, let M be adjacency matrix of graph G given below, where Mij is equals to 1 if there is H from I to J, otherwise 0. So when we write this like this, I, a matrix, and then ij, it means what? This first one is basically a row. This means basically a column, right? So from this matrix, this ith row and jth column. So if we have ith row, jth column equals to 1, it means what? We can say there is an h from I to j. So from this particular matrices, what we can say? Okay. So I know we have 6 by 6 matrix, so vertex will be 6. Here I know how many ones we have. 1, 2, 3, 4, 5, 6, 7. There are 7 ones. It means what? You can see here like this, right? So we can go if it's a directed graph like this. So we have 7 vertices here, right? 1, 2, 3, 4, 5, 6, 7, like that, right? This thing we can know. Also from this particular graph, I can get this information if m, let's say for example, 3 comma 3 and then we have 4. Now here m3 4 means what? Third row, fourth column. Third row, fourth column is what? 0. That will be 0 like this. And this also telling us the information that there is no h from 3 to 4. Can I say like this? There is no h from 3 to 4, right? So
Yes,
this
sir, we will.
adjacency matrix is giving information about that entire graph here. Okay. I hope everyone knows how to draw adjacency matrix for a given graph, and if matrix is given, you should uh, infer few information for this particular for this type of graph. Okay. Any question here up till now? What we have discussed? Okay, great.
No.
So what about this particular pseudocode now? So we have drawn the matrix. So procedure, we are going to update that particular matrix M what we have drawn. Temporary matrix equals to M. So whatever we have the matrix M, we are storing it at this temp matrix. Now for each I in rows of M, columns of M. Whenever you see this rows of M, columns of M, it means what? It will give us list of vertices of matrix M. Okay. So this will give us list of vertices of matrix M. So list like this 0, 1, 2, 3, 4, 5, like this. Okay, this is the list. Now for each I in rows of M, for each K in rows of column, what we are checking here? Yes, anyone?
We are checking, every possible vertices.
Yeah. So how this for loop will work, nested for loop? So for the first iteration, you can see outer for loop I will be a 0, and then here k will be 0. So again we are checking if 0 0 is equals to 1. No, right? Then we'll not do anything here. We go back to this inner for loop, then we'll say we'll go to next element, that is 1. Again we'll say 0 1. Do we have any age? Let's say we don't have any age from 0 to 1, then again we'll go back to a inner for loop. So like this, we'll first complete the inner loop for loop for the fixed value of I. That's for initial iteration 0. Then we'll increase the value of this k. So by this next element 0, 1, 2, 3, 4, 5, like that. Okay. Now you can see at this particular point when 0, 2, yeah. So when if we go again and if I say k is equals to 2. Now here you can see I is 0, k is 2, I is 0, k is 2, equals to 1. This satisfy my condition. Then what we have to do? Then see. So here I is 0, k is 2. For each j in columns of M, again same a list of vertices. Now what we are saying? If k j equals to 1. Now the value of k is fixed here because we have checked this condition. Inside this if condition, we have this for loop and if condition. The value of k is fixed. Now we are iterating through this for loop for the value of j here from 0, 1, 2, 3. Now, can you look at the graph and tell me for which value of j this condition will be true?
One
Only
and
one?
and three as well. Yeah.
Yeah. So how we decided that? So we have fixed the value of this k to 2. Now here our row is what 2. So from 2 where we can go? From 2 I can go to 1, I can go to 3. So it means what? At the matrix M we have this 1 1 there, right? So if you see this matrix M here now, I can this that condition will get satisfied for what? This 1 and for this particular 3, right? Now here you can see. First, let's say for example, j equals to 1, that condition got satisfied, right? In that case, what will happen? So this 2, 1, satisfying my condition. Now what we are doing here? The temporary matrix what we have created, we are going to update that ij1. Now what is I? 0. What is j? 1. So we are going to update that into a temporary matrix equals to like equals to 1 here, and then we are going to return that, okay, like that. Okay, so here we can say temporary matrix same as a matrix M here what we have created a copy here. So 0 1 it will be equals to 1. So in the matrix temporary matrix 0 1, so 0 row first column will be replaced by 1 here, okay, will be replaced by 1 here. Okay, this is what we have done. Now same goes for a next iteration. If we continue for a next for loop, value of 2, no. But what about value of 3? Yes. When k equals to 2 and j equals to 3, again this condition will get satisfied. Again we are going to update this by what? Again I is 0, but here j is what? 3. So 0th row, third column, we are going to update by 1 here. So 0th row, third column. So 0th row, third column, we are going to update that by 1 like this. Okay. And in this way, we are going to complete the inner for loop. Then we'll go for a outer for loop. Then next value of I will be 1 like that. And same process is going to get repeated here. Any doubt how we have gone through this entire pseudocode? Anyone?
So just one question here in the temp mat ij when we are updating this to 1. So we
Ah.
are we really checking if there is a direct edge from I to j?
Here we are not checking. Here we are updating I to j equals to 1, right? So if there is no h, then we are going to update to 1. If there is also an h, still it will be a 1 only in the matrix. Like that.
Yes. Okay.
Yeah.
Okay.
Because after this updating, we are going to return this particular matrix M only, template matrix, and that procedure is going to update our matrix M like. Okay.
Okay. Okay.
So if you understand this, then you can see this question, right? So I have discussed just for a one example, but you can see this type of questions, right? So new matrix equals to what? Update matrix M. Now that matrix we already calculated. Now we are going to call this particular procedure to update the particular matrix. And based on that, we have the value of P and Q. Now P will be what? 0 and 3. So 0, 3. So 0th row, third column. So you can see 0th row, third column is here updated by 1, right? So in this case, the
Yes,
value
sir.
of that will be 1. What about Q? Matrix 3 and 4. So we have not gone to the I equals to 3 here. You can see 3, 4. But can we directly solve this question for this particular case without drawing the matrix and all those things? What you can say about this particular pseudocode? What we are actually doing here? Yes, anyone?
You are computing exact the at most
Sir,
one
one
of
of concept
the at most one of concept.
in
Okay.
this question use one of concept.
Yeah. So you can see here we are checking this condition. If I can go from I to K, and then we are checking if I can go from K to J, like this you can see here, right? then only we are saying I can go from I to J like this, right? So here I to K, K to J, then we are updating it to I to J, right? Now, what is this? Q. We already calculated by conventional method, but what about Q? 3 and 4. Here I is 3, right? So, and 4. Now, what we can say about 3 to 4? Can we go to 3 to 4 with the one hope here?
No, so we can't go. We
Yeah,
would need
No,
two
sir.
hops,
no.
We have two hop
Yeah,
three
for
hops,
so that,
go three
three
to four.
hops.
yeah. So here you can see that will be a 0, right? So 1 0 will be the answer. So option number B is correct here. Now, if you understand this, we can ask any question here. Like, for example, what will the value of a new matrix, let's say 3, 2? In that case, what will be the answer? Can we go to 3 to 2 with one hope?
Yes,
Yeah,
it's
we
1.
can go directly like that. 3 to 5, no. 5 to 3, like this we
Yes,
can
Yes,
1.
go,
sir.
right?
5 to 3 we will go.
So, whenever you can see this I to K, K to J, and then we can go I to J. For example, I can add one more for loop here. Let's say I am adding one more for loop here for each Z in, let's say again, rows of M. In that case, again, I am checking and M of K Z equals to 1. And then we are following this particular process. In that case, what we can say?
The
So
at
I have
most two hop condition.
hope, okay. So I can go from I to K here and from K to Z directly. If this condition satisfied, then we are saying Z to J. Sorry, K to J. So here it will be I. Yeah, here it will be I. It will be Z. So I can say we can go directly. So then I can say I to J directly. Okay. So do understand the pseudocode first. What we have given in that. Okay. Then you have to answer those questions. So understanding the pseudocode is very important. And here you can see this is what we have done. So first step is what you should know how to draw the adjacency matrix, because if you didn't understand how to solve directly, then you can go for this particular approach. It will take time, but you will get the answer. Okay. So this is about this particular question number 14. Any doubt here? Anyone?
No, sir. No doubt.
Okay. Now what about question number 15 here? What we are trying to do here? Yes, anyone? So this new matrix is what we have updated previous question. Now new matrix 2 is what? We are taking this matrix as an input here. Now we need to find out the value of P and Q. Now tell me how to solve this type of question. What you will do?
That's the two hop question. It computes the two hop, at most two hops between 0 to 3.
Between 0 to 3. Okay, so how directly you can say at most 2 hope?
So from 0 to 3, because it should also include one hop. So that
Hmm.
should be 1. Because since at most is, so the maximum should be 2.
Okay.
Okay, just from the first line, it should we should conclude that it should include one hop, because the first line includes the one hop condition. So one hop gets copied into the second line, so it then becomes the two hop condition. So one hop is copied into the second line.
At most we can say, right?
Right.
Yeah. So new matrix 0 and 3. Now just go to a matrix. Can we go from 0 to 3 here?
No, sir. One hop.
But still it will be 1 only na, in the matrix. In the matrix, we already computed this 1, 0 to 3, already they are 1, right? And then we are taking this as an input again. So anyway, this 1 will be there, right? So this 0 to 3 will be 1. We can go from 0 to 3, okay? And then we are taking this as an input, and again, but anyway, this will be a 1 only, right? So the value of P will be a 1 here. What about 3, 4?
2 hops, sir.
It would remain 0 because that's at most 3 hop condition, not the at most 2 hop condition.
3 to 0, 0 to 2, 2 to 1, 4. It will be 0 or what?
Yes, it should be 0.
Yes, sir. 0, 0.
Okay. So let's say for the first new matrix 1, okay, where it is matrix 1. Yeah. So matrix new matrix 2, 3, 4, right? So let's say matrix 1 only this particular matrix 3 to 4, right? So here you can see 3 to 4 will be what? No. But from 3 where we can update this matrix to this one, I can go to 2, 3, 0, 2, 2 only, right? So
I can
this
also go to
will,
0, right?
yeah, 0 already there na here in the matrix updated. So we are
Ah,
going to update this by 1, okay?
mm.
This is done. Then we are going to take this as input, right? Now if I take this as an input, then we are checking, right? Because this will be taken as an input, this 3, 2, right? Also, new
Okay, we
matrix
can
2.
also go to 1 also, right? If we allow at most 2 hops, that's also possible to go to 1.
To go to 1.
Yeah.
No, no, I am just checking for this update matrix 1 only, not 2. Okay, so new
Okay.
matrix 1.
Okay.
So in the previous code, here what we have said, right? So we can go to 3 to 2 directly, right? We have one hope. That is what we have discussed. So we are going to update this matrix to 1 like that, right? Is it clear? Now we are going to, yeah, and from 2 also where we can go? From 2 we can go to 4. From 2 we can go to 0. From 2, 0 and 4 only, right? So we are going to update this to 1. We are going to update this to 1. Now this matrix will be taken into a input to the new matrix 2 like this. Okay. Now see what is going to happen. Now let's see. This is what our matrix is I, right? Let's say I equals to 3 now. Now see when value of I is equals to 3. Okay. This is what it is. So 3 to 0 we can go. So for the first 3 to 0 this will be correct. Again we are checking uh, 0 to where we can go. 3 to 0 we can go. 0 to 2 we can go. Okay. And then 3 to 0, 0 to 2 we can go. Then 3 to 2 we can go. Yes. In the next scenario we can go to 2 directly. So 3 to 2 we can go. So here value will be 2. But from 2 where we can go? From 2 we can go to 1 as well. Right? Then we can say here is 3, J is what? 1. So 3, 1 will get updated like this. So 3, 1 will also get updated like this. Right? Yeah. Then that's it, right? But we have 3, 4 here. 3, 4 will be updated to 0, I guess, right? Yeah. So answer should be 1, 0. That is basically B here, right? Answer is D here, right? 3, 4 matrix. Can we go to 3, 2, 1 here from the previous case? No, right?
So now you are considering the update matrix 2, right?
Yes.
So now we can go to 1, right?
We can go to 1 directly, but
Yeah.
here from 2 to 1, right? 3 to 1, we cannot go. Yeah, indirectly.
Yeah, 2 to 1 you cannot go because yeah.
Okay. Yeah. So answer should be B here. We'll see why this option D is given here, right? So same here, 3 to 4. So from 3, I can go to 0 to 2, and from 2, I can go to 1, right? This is what it is. So from previous iteration, we have updated 3 to 2 to 1. So this is what we have done. And then if I take this input again, then here what will happen? So from 3, I can go to 0 and 2 only. So 0 and 2. So from 2, 3, 2, and then we have 2 to j, right? 2 to 1. So that will be a 3 to 1 only. Yeah. We'll see about this question. Yeah. Option B is correct here.
Why is
Okay.
option D correct here?
No, option B here. We'll see. Something is wrong here. Okay. Because 3 to 4, we cannot go directly, right? So from the previous iteration also, like previous new matrix one, it will get updated with what? 2 only, right? So 3 to 2 only. This will get updated. 1 also will get updated. No, 3 to 2 only, right? So 3, then we have 3 to 0 we can go, then 0 to 2 we can go, then 3 to 2 we can go, then we'll update. Yes. Then, yeah. So if I update this matrix 3 to 2, hmm, yeah, okay, this is correct. We'll see. Okay, so this type of question you should be able to go through that, but please check how many for loop is given, what condition is given to you, and then accordingly you need to update that. Okay. So the diagram will get changed, the code will get changed, and accordingly the answer will be different, right? So do see the code carefully. Okay. Anyone, any doubt here? What we have discussed? Okay. Huh? Yes.
Yeah, previous one, uh, I'm not clear because you're scrolling up and down, no, so I cannot able to understand what is how to solve this one actually.
Previous question.
Yeah.
No. Okay. Did you understand how we solve the question number this one 14?
No, I
Can you
joined
speak
late.
little louder? Arun, is
I
it for
I,
me only?
I
Your voice
joined
is low.
now okay.
Yes, now okay.
I joined late only, so that's why I'm able to understand. And
Okay, see here. So we have given this particular graph and the pseudocode. So first we discuss about how to draw adjacency matrix for a given graph. This is what we have done. Okay, so I hope uh, you know how to draw adjacency matrix, right? So whenever
yeah,
there is age, we can
yeah,
update it to 1. And for this undirected graph, both I to j, j to I, we can update to 1, right? Like that.
okay,
Now we are going to take that matrix as an input here for this particular procedure, and we are going to perform these operations here. So
okay,
for each I in rows of column, for each k in rows columns of m. So here columns or rows will give me what? List of vertices. List of vertices of matrix M, that is 0, 1, 2, 3, 4, 5.
okay,
Now here we are checking condition. So we'll go to a nested for loop here. When I equals to 0 initially, then we'll go through all the element of this columns M. So 0, 1, 2, 3, 4 for this particular condition. But we already know that by looking at the graph, when the value of I is 0, for what value of k this will be equals to 1, this will be true. So we can say here from 0 to 2 we can go. not to 3, not to 1. So whenever the value of k will be 2 here, then that point only this condition will get satisfied. If this gets satisfied, then we are going to do all those things. Then again, we have a for loop for j in columns of m, same thing here. Now here the value of I is 0, k is 2. Now we need to check for which value of j this condition will get satisfied here. Okay. So if you see 2, right? So from 2, where we can go? From 2 to 1 we can go, right?
Yeah.
Not to any 2 to 3 also we can go. 2
Yeah.
to 1 and 2 to 3 directly. So
Mhm.
whenever the value of j is equals to 1, so that will be 2, 1. This will get satisfied. Now we are going to update that matrix 2, 1 equals to 1. It
1.
means what? Second row, first column. So
Yeah.
second row, first column. So second row, first column, that is what we have updated to 1 here, right? So 2
Yeah.
to 1. We can go, sorry, not 2 to 1, but here it is I, right? So I
Yeah.
is basically 0. So 0 and j is basically what we got 1,
1.
right? So 0 to 1, we are going to update it to like this. Here we have updated, okay?
Yeah.
Same process we are going to do. Again, 2 to 3 I can go. So for what value of j it gets satisfied? 3. So again, 0 to 3 we can go. We can go means we have one uh, intermediate vertices. So 0 to 3 we have updated like this. Okay.
Mm.
So again, we can see here like this. We'll proceed for each and every node. Okay.
Okay.
Yeah. Same thing will go when the value of next iteration value of I will be equals to 1. So again, we can go to 5 only, right? So 1 to 5 will get updated, 1 to 4 already there. So 1 to 5 will get updated like this. Okay.
Okay.
Okay. Great. So please try to solve this type of questions. Okay. If you have any doubt, you can ask in the next session also. No worries. Yeah. So we discussed this question number 14 and 15. Let's try to discuss this question number 17 and 18 here. Okay. Same based on the matrix only. So the following pseudocode construct a graph G using the scores data set represented by the adjacency matrix B. Let A be the dictionary with sequence number of students as keys mapped to their total mark. So this is using the scores data set. We know that every row in the scores data set indicate what? One individual student, right? So we have drawn the matrix for that. And dictionary with sequence number of a student as key mapped to their total marks. Okay. So how many sequence number we have? Let's say, for example, in our data set, we have 30 students, right? If you remember data set, so length of keys. So what is this keys function? What is this length function? Anyone? A is dictionary basically. And here sequence number, then the corresponding value is marked to their total marks. Okay, this is what for every student we are doing like that. 1, 2 like that. So number of sequence will be what? So keys of A. So whenever you see this A, right, that is dictionary. So keys of dictionary will give us what?
The list of values,
List
list
of
of keys.
keys. List of keys. Okay, so that will be sequence number 1, sequence number 2 till sequence number n. How many key we have? What about the length function?
Returns the length of those. So it gives me
Yeah.
the vertices, dimension of them.
Length of list will be number of element in that list. Number of elements in list, right? Now here you can see, let's say for example, we have 30, so that will be 30. Let's say we have 5 students, then it will be a 5. And then we are going to create a matrix of n by n. So that is what we have discussed. Let's say here 30 by 30 matrix for this score data set. Now what we are trying to do? For each I in keys of A, for each J in keys of A. Keys of A means what? Again, list of keys here. And keys indicate what? Sequence number here. You can see a sequence numbers. Now, what is this A of I? What we can say about this in
The
general? What
total,
is this?
the total marks for I student
Yeah,
with
total
sequence number
marks.
I. Yeah.
Yeah, total marks for a sequence number I, right? Same here for J as well, because for the first iteration, sequence number will be, let's say, 0, and here also 0. So we are checking whether the, so here it is dictionary, here it is key. So value corresponding to a 0 sequence number is greater than value corresponding to 0 sequence number. That anyway will not be correct. Then we go for a next iteration. Here value of J will be 1. So here like that. Then again, we'll check the total marks of 0th sequence number versus the first sequence number. If 0th sequence number total marks is greater than the first sequence, then we are going to update the matrix B by what equals to 1, like that. Okay, so this will do for all the rows. So what we are doing here, we are taking one student. This is how nested iteration will work. Nested loop will work. So we are taking I equals to 0, sequence number 0. We are comparing with all other sequence numbers, right? All other student total marks. If total mark is greater than, like for whichever the student, this sequence number 0 is greater than that particular student, we are going to update it what? Bij equals to 1, like that. Okay. So this is how this entire pseudocode will work. Any question like how the pseudocode is working? Yes. No. Let's say we have this sequence number, we have a total marks, and let's say we have this 0, 1, 2, only 3 students are there. Let's say total marks are 200, 250, 220, like that. Okay. So here the list will be 0, comma 1, comma 2. And in the dictionary, that value will be 0 correspond to 200, 1, 250, and 2, 220, like that. Okay. Sequence number corresponding total marks you have added into a dictionary, and this will be a keys. Now what we are doing here, when I equals to 0, j also 0 for the first iteration. So anyway, marks at 0th key will be what? 200 greater than 200? No, not correct. We'll go for a next iteration. Value of j will be 1. So again, we are checking here I0, j1, right? So again, marks at 0 sequence number is 200 greater than the value at first sequence number, it is 250. No, again not correct. So we'll go for a next iteration. Value of j will be 2 here. Again, we are updating, checking here the total marks of 0 sequence number greater than the total marks of second sequence number. No, 200 is not greater than 220. Not true. So we'll go for a next iteration here. But we don't have any elements in the this keys of A. Then we'll go for a outer for loop here. And then we'll update I equals to 1, like that. Then again, we are going to compare with every value of these keys. Okay, so the next iteration I will be equals to 1, and here j again will start with 0. So this I and this 0. So again, we are checking whether the value at sequence number 1 is what? Total marks is 250. And what is the total marks at sequence number 0? Let's say 200 here. 250 greater than 200? Yes. So at this point, our condition is getting satisfied. Then only we are going to update it to a B in the dictionary. Dictionary means in the matrix here. So B at ith row and jth column means first row, 0th column, that will be equals to 1, like that. Okay. So in this way, the entire pseudocode will work. I hope this thing is clear now.
Yes.
Okay. Now, if you understand this pseudocode, let's read the question. Choose the correct options with respect to graph G. So G is always a cyclic. Can we say G is always a cyclic? What is acyclic and what is cyclic graph? Yes, anyone?
Yes, cyclic means if I to j is 1 and j to I is also 1, or I to j is 0 and j to I is also 0 for any
Yeah.
ij.
So if I can go like this, okay. So there will be a cycle like this. I can go 0 to 1, 1 to 2, 2 to 0 again like this. This is a cycle, right? So if we don't have this type of loop or a cycle, we can say it is a acyclic. So can we say this condition is true? This is always acyclic.
Yes, sir, because it's not required because I mentors J here, but J cannot mentor I here.
Sorry, can you repeat? I am enter
Yeah.
JH.
Yeah, because I has greater marks than J. So
Huh.
there is an edge from I to J pointing towards J, but
Hmm.
the other way is not correct. But otherwise would have been correct. We have invoked the other condition for A of J is also less than I.
Yes. So if you see this one, when we are going to update to 1, when this condition satisfied, it means what? The marks of 0 is greater than the marks of 1. This is what we are saying, right? Let's say 250 greater than this 200. Then only there will be a row. Same thing here. The marks of this one is greater than this second player, the second student. Let's say, for example, here 150. But is this possible? 2 to 0. Marks of second student 150 is greater than a 0? No, this is not possible here. You can see, right? Because when we are saying equals to 1, only this condition getting satisfied. But here this will not get satisfied. So this will exist. But again 2 to 0 will not exist like that. I hope this thing is clear, right? What I have explained.
Yes.
Yeah. So it will not be a cyclic here. No, option A is not correct. What about option number B? Yes.
It is acyclic, right? Because there are no cycles here.
Oh, sorry. Yes, it is a cyclic. Yeah. What about B?
Yeah, that's also wrong.
So if Bij equals to 1, then Bji equals to 1? No, we cannot say like this, okay? Because if I say 0 to 1, we can go because 250 greater than 200. It doesn't mean that 200 greater than 250, right? So we cannot go here unless this condition is getting satisfied, right? So B is not correct. What about C?
It's correct.
Yeah. So if marks of I is greater than J, so marks of J cannot be greater than I, right? Anyway, so that will be a 0. So option C is correct. What about D?
It's also wrong because for this to be correct, J should be greater than I.
Yeah. So here we are saying if I equals to J, then this reverse will be true, but not this one, right? Yeah. So option D is also not correct. So only option A and C are correct here. Anyone, any doubt in this question?
Here, that option explained, it's not possible, you told, right? So 150 to 250. So G is always cyclic means
Yeah. There
the
will be no
explanation.
cycle.
Okay.
Huh?
So cyc it is it is always cyclic, right? So
This is correct. It is always acyclic. There will not be any
acyclic means
cycle.
not cycle.
Huh, not cycle.
Okay.
Yeah.
Okay.
Right. That means 0 to 1 we can go, 1 to 2 also we can go, and 0 to 2 to 0 also we can go. This is a complete cycle here you can see, right?
Yeah, I understood this one,
Yeah.
but the wording maybe I confused. Acycle
Okay,
means
okay.
it's a non-cycle.
Yeah, non-cyclic. Yeah. Okay. Now, same thing, but here what we are doing, same matrix. So we are going to use the matrix what we have created above by using this pseudocode, and then we are going to solve this question. So what? So when will be the procedure check something bi return true? So b will be what? What we have created in the previous question. I, we are taking this as an input. So for each j in columns of b, if I is not equals to j, if I is not equals to j and bij equals to 0, then we are going to return false. Otherwise, it will be a true only. Okay. So what is this? So I is not equals to j means we are not comparing the same student here, right? So student should not be same. That's what we are checking here because I and j indicate a sequence number. So sequence number should not be a same and bij is equals to 0. Then only we are going to return false. Otherwise, it will be true. Now, what about the option number A? Is this correct? What we can say? So when this possible return true,
This I should be greater than J. only then it would be 1, and hence it returns 2.
So it means what? When we say it should return true, it should not return false, means this condition should be false, right?
Yes.
Now this entire condition will be false when. So anyway, this we are checking for two same student, right? But and condition is there. Now when this condition will become false when Bij equals to not equals to 0. Not equals to 0 means let's say 1 here, right? And we already know when the marks of total marks of I greater than of j, then only the value of Bij will be equals to 1, right? So if a student I has scored greater total marks than at least one student is correct here, or let's see other option. Has scored less than total marks than at least one student.
No, that won't be true. Second option is going to be true. Right?
No. Less than, no. Greater than, we can understand. We'll see this particular option. What about C?
C. So can you scroll a bit down?
Yeah. Okay.
Yeah.
Anyway, answer is C. Yeah. So
Student
I
type
has lowest total marks among all students.
no. It should be highest total marks.
Yeah. So why highest among at least or among all? So this is the only thing here, right? So what is at least? What is among all the students? How we can say from here?
Okay, for the so if we look into the first code, the B matrix that we computed. So here, for this to be true, so for every I should be greater than for every J. So only then it returns true. If there is a statement like I comma J for some student, if it's I less than J, it might be possible that I scores less than J in for some cases. So then this returns false for that case.
Okay, so even for one student, if this condition got satisfied, then it is going to return false, right?
Yes.
Yeah. So in order to return true, the marks of I should be greater than all other students, right? Then only this will return. This will not get return false. It will return true. Because for any value of j, if that gets satisfied, then this will be true, and then it will return a false, right? So student I has scored highest total marks among all the students. For that student only, this will return true. For other student, this will get true. Okay, so that's why. Any question? How we got this one? Okay, great. So do try to solve this type of questions. Okay. Now again, we have this question based on adjacency matrix here. Okay. Yeah. So now see here, those who didn't understand or joined late in the previous questions. So again, you can see we have a adjacency matrix M for the given graph. So we can draw a adjacency matrix directly, but we can solve this question as well. Okay. So this is given to us, and adjacency matrix will be what? Whenever there is a h, so like for example, 0th row, first column will be 1, 0th row, third column will be 1, 0th row, fourth column will be 1, second row, fifth column will be 1, like that. Okay, you can see like that. Now, what about this procedure? What we are trying to do here? So procedure do something M comma Q. So M is basically adjacency matrix. Q, we are going to take the input in count 0 for I in rows of M. Rows of M, again the list of vertices. If I Q, so we are taking this as an input, we are checking Q here, then only we are going to count equals to 1, right? So let's say what's the first question here? Do something M3. So the value of Q is 3 here. Let's see what the value of count we are going to get. Now tell me how we are going to approach this question now. So here count is 0. I in the rows of M, that will be a 0, 1, 2, 3, 4, 5. List of vertices. If I, so I will be 0. Q is fixed here 3. Now for which value of I this condition will get true? Yes, anyone?
Only 0, 4, and 5.
0, 4, and 5, sir.
Because we know the value of q is 3 here. So I want to find the value of y when this equals to 1. So 3, right? So q is 3. So you have to check the incoming arrow in this particular case because we are checking for a column here, right? So 0 and 4. So when the value of I is 0 or 4, this will be equals to 1, right? But also here you can see, or we are also checking 3 to columns. So here you can see this particular thing, 3 to I, right? So here we get so this condition will check for incoming arrows, inward arrow, and this condition will check for outgoing arrow, right? Like this. Okay. So here comes the concept of degree of vertices. Anyone know what is degree of vertices?
Just the number of arrows pointing or indirecting or out directing from that vertex.
So degree of vertices. If I just ask for a degree of 3, in that case, it will be a total number of arrows coming in or going out. So 1, 2, and 3. When I say in degree means what? Incoming arrow, that will be 2. Out degree means what? Outgoing arrow. Simple a concept as name suggests, that will be 1. So in degree plus out degree will be a total degree of any vertices. Okay, you can remember this point here. In some of the questions, in the previous year questions, we have asked the question based on this as well. Okay. Now we know that for q equals to 3, so first this will get satisfied for what? When the value of I will be equals to 0, this will get a true, right? So count will be equals to count plus 1. So value of count will be 1. Then go for a next iteration. Again, for value of 0, 1, no, 2, no, 3, no. What about 4? Yes. 4, 3 will be true here. Again, count will increment by 1. That will be a 2. Go for a next iteration. 3, 5. Now here the value of 3, q is 3, and but here it will get 5. This will be false. 5 to 3, this will be false, but OR condition is there. So OR 3, 5, right? So we can go to 3 to 5 here, you can see like this. So this will get true because OR condition is there. So answer will be what? Again 2 plus 1, that will be the 3. Okay. So answer will be a 3 here, you can see. Anyone, any doubt here?
So,
Yes.
actually, which week's assignment is are you discussing now?
Sorry, which?
Which week assignment? Is that week
No,
3
no.
or?
Here we are discussing previous year questions, previous term questions.
Oh, okay. Where can I access these videos?
No. So we have this access. So we are discussing that. If you have any question, you can ask. Okay. You can
Yes,
check.
sir.
There are few websites. So you can see those questions, right? Student might know. Yeah. Okay. So you can check with previous term student. They can share with you. Okay. So here, if I just replace by and, then what will be the value of count here? Yes, anyone?
Yeah, then it should be only 0, right?
Yeah, because 3 to 5 and again 5 to 3 will not be a possible like that. Okay, unless we have a only single
Yeah, incoming.
directed arrow here.
Directed edge.
Yeah, directed edge. Only in that case that will be a 2. Okay,
If
so
anyone of this becomes false, then the entire thing becomes false. We return
false.
0.
Yes. So this will be true only in the case of directed edge, like 3 to 5. We have, sorry, undirected edge like this. Don't have any arrow. Yeah. Again, same thing, same question, but here instead of 3, we have a 4. So for 4, what we have to do? Again, you can see
With 2, right?
Sir,
4,
2 answer would
4.
be 2.
So here 0 to 4, it will be 1, and again 4 to 3 will be 1, like that. Okay. So here count will be equals to 1. Okay. So what if we have OR only, but here Anyway, answer with 3 only. Okay. Okay. So do check the pseudocode and try to apply it to a graph. Okay. So it will be changes here. We can add any condition or we can add one more for loop here. Again, add one more condition like that. Okay. So it depends. So do check when this will become true. If condition will become true. And then what we are doing after that, that you need to see. Okay. Same thing what we have discussed here as well in this question as well. You need to check for this condition when it will get true because anyway this for each what it is doing simply going through all the vertices. Okay, so you need to check whenever the if condition will be true. It can be only one condition here. We can add one more condition with using and or or. So you have to see for which node this condition getting true. Then after that again entire for loop. Then what is the value of k and for which value of j this is getting true. So all this thing you have to see in the pseudocode. Okay. I hope this thing is clear. Okay. So this is about this type of question you can expect in the end term exam from week 9 to 11 because all are basically a graph questions like that. Okay. You can see. Any doubt you have or any questions from week 9 to 11? Yes, anyone? Okay. So we have one more concept of recursion. What is recursion? Yes, anyone? Tell me.
So function calls itself over again.
Yeah. So function call itself again and again in the same code, right? So do something. There it is.
Sir, please explain this question.
Yeah.
Last,
Yes. So
last.
this recursion part, na?
Yes, sir,
Yeah.
thesis.
Before that, we'll discuss question number 10 because it's using this procedure. Okay. So here we have a and b positive integers. Procedure remainder a b returns remainder if a is divided by b. So we have already defined what this procedure is doing. So whenever we say remainder 10 comma 3, so remainder 10 comma 3 will be what? 1 here like that. Okay, so it is going to return the remainder. When we say 16 comma 2, that will be a 0 like that. When we say 21 6, 21 comma 6 remainder will be 3 like that. Okay, so simply a remainder function and what we are doing j equals to 2. So we have defined the value of j flag equals to true. If x equals to 1, so what we have to do? Return false. Otherwise, we'll go to a while loop while j is less than x and we will check x divided by j equals to 0 and then we are going to return flag equals to false and here we have to exit loop. So at line number 9 when we execute line number 9 we have to exit this entire while loop here. Okay, and then we have to return whatever the value of flag is. Now let's try to implement this pseudocode on the question number 10. What will when the procedure do something will return true. Okay, so do something. So x is prime number even odd more than 1. So we have four options here and we need to check when this will return true. Even odd prime more than 1. So we have even, we have odd, we have prime more than 1. Okay. Yeah. Now tell me for which value of x. If x is even, let's say for example 4, this will return true. Can you check? Anyone?
Yes, this will always return true. I mean, this won't return, sorry, won't return true, it would return false because this would return remainder to be 0.
Okay. So when we say even, so any value, let's say 2, 4, 6, 8, any which is not equals to 1, so not going to return false. Go for a while loop, J2. So always consider value of x greater than 2 because here we have started with j equals to 2. Let's say 4 here. So 2 less than 4. Yes, correct. Here we are checking x. X is 4. J is 2. 4 divided by 2 remainder is 0. Yes, this is true. Then we are going to set flag to false, exit loop, and return flag equals to false. So when X is even, we are going to return false. Is that correct?
Yes.
Yes,
What
sir.
about
This
odd?
is correct.
What about odd?
If we take 5, so 5 comma 2, remainder is 1.
Sir, I have a doubt in first condition, sir. Third line, if x equal to 1 means that condition, how is that one?
When the value of X equals to 1. So in that case, it will likely return false.
Then you assume that x is equal to 4 means now it became
Yeah, this
true
is
only,
false.
no?
Na? Yeah, this will be false then. 4 is not equals to 1, right? This is false.
False, then
So
it
we are,
return true, is right?
sorry?
If 4 equal to 1, so the condition became false, is right?
Yes. So here we are checking the whether the value of X is equals to 1 or not. That is what we are checking here. Okay. So you can see directly when the value of X equals to 1, this will return false. Okay. What about the odd one?
The odd one, likely if we take like 5, 7, it would return true. But let's say if we take
Let's say for example 9. What will happen in the case of 9? Anyway, not equals to 1. J is
Yeah.
2, X is 9. 9 divided by 2, is it equals to 0?
No, it would return true.
No, it will not return true.
It will
So
return
here,
false because in first loop it will not be there, but when j value will increase, then the remainder will be 0 and then it will become false.
so see, at this moment, remainder will be 1, so not correct, so we'll not do anything. Okay, so here we have if, then we have to increment the value of j to 2 plus 1, 3. Go for a next iteration, value of j will be 3. Now what about 9 comma 3?
Okay, this returns false then. Yeah.
This will be true, right? Because 9 divided by 3 will be true, and then it will return false, right?
When it return true, sir, flag will become true in 8th line.
Flag will become false, na here, line number 8.
Okay, no, I'm asking when
Huh.
it exit the loop, which
Yeah. So once the flag is equals to false, it will exit the loop. Okay. So you can see if condition here. Whenever this condition will become true, we are going to return false and it will exit the loop. That's it.
oh,
Okay. So whenever this condition gets satisfied, we are going to exit the loop and we are going to return flag equals to false. It means what for odd number also this is false. What about the prime numbers? What is prime number here?
It will return true.
Greater than 1, anyway, we have checked for 4 as well as 9. This is also returning false, right? Now only for prime numbers. So prime numbers will be divided by itself or 1 only. But anyway, j is not starting from 1, right? It's starting from 2, right? Now let's say for example 13. So anyway, 2 less than 13, yes, 13, 2, not, remainder is not 0, divided by 2, not 0. Check 3, no, go 4, no, 5, no, 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 right? But what will happen here? So when the value of j is become 12, here it is 13, value of j is 12, not correct. We are incrementing value of j to 13. Now again we are going for a while loop. Now what is happening here? Is
Not interested while
13
left.
less than 13?
No.
Condition is false, we'll exit the while loop here. We are not going to check here, right? In that case, whatever the value of default value of flag will be, that will get returned. So in the case of prime number only, this will return true. Okay. Any doubt in this question? So prime number only. Yeah, option A is
What
correct.
is happening up to 13, I understood, but up to 12, then the remainder is coming, again, it won't execute. Then again, increment is 30,
Yeah.
then it will be 0, right?
So yeah,
Then-
if I select 13 as a number, initially it is 2, not divisible by 2. So anyway, we are not going to do anything. We'll increment the value of j to 3. Again, check 3 less than 13. Yes. But anyway, 13 is not divisible by 3. Again, not going to update. Again, increment the value of j. Same thing we are going to do, increment the value of j. Because anyway, 13 is a prime number, right? This will not get true.
Yeah.
Yeah. So prime number will be, remainder will be 0. Only the value of j is 1 or the number itself. But anyway, we have started with a 2. So that will not be a case. But anyway, here we are checking for this condition. So in that case, 13 is not less than 13. Okay. In that case, that will exit the loop here. Okay. But if I put this condition less than or equals to x, in that case, it will always return false, right?
Yes.
Yeah. So do
Now,
check this small things.
now what is then now what condition it's the flag will be true actually?
No, if I just replace with less than equal to, this will be always false. It will always return false because for at least for one condition, this will get true. Whenever the value of x and j is equal, both are will be divisible, right? So in that case, this will be a true, and this will always return false. Okay. So here we can change the sign less than equals to. We can add one more question that it will always return a false like that. Then you should be able to get that. Okay. So do understand what pseudocode is doing here.
Sorry to interrupt. Actually, what is the answer now for this
Prime number.
prime number?
Yeah.
But 13, if it is less than 13 up to 12, it will go, then again incrementing, right? So then this condition, while condition won't execute, right?
Yeah. So after when the 13 and 12 is there, this will not be true. Value of j increment to 13. But here you can see if I go to while loop, 13 less than 13. This will not be a correct. Na?
Yeah.
So
So,
here we are exiting the while loop. That's it.
it's exit from the while loop.
Yeah. Whenever the
Then, yeah, okay.
condition is false, we are going to
Then
exit the while loop.
initial set value, it will be returned.
Yes, because we have not updated anywhere, right? So initial value will
Understood.
get returned.
Okay, got it.
Okay, great.
Hello, excuse me, sir.
Huh?
Sir, like, will we have revision for end term like we had for quiz 1 and quiz 2, sir?
So this is what we are doing. We are discussing previous year questions only, na? Previous year term questions.
Yes, sir.
So in the
Like even in the like future sessions, like day after tomorrow and after that, will we have revision session or what, sir?
yeah, Friday we have session.
Friday and Saturday, sir, because Friday will cover week 1 to
No,
9 and
in Saturday's session, we have covered week 1 to 4. In Monday's session, we have covered 5 to 8. Today, we have discussed the concept of graph theory that is from 9 to 11. Okay.
okay,
So we
yes,
discussed everything. Friday, it will be a doubt clearing session, or if we have any question from previous time you are not able to solve from any assignment, you can ask. Okay.
okay, yes, sir,
So you can watch Saturday's session, Monday's session, and this session. Okay.
yes, sir.
Because week 9 to 11 is simply a graph theory. So if you are able to understand how to solve this type of
Yes, sir.
question,
Only adjacency matrix related questions.
yeah.
Sir,
Okay.
like, so week 5 to 8 was done yesterday, sir. No,
Yes,
no.
yesterday.
Sir, no, I guess it was done last week.
No, not Monday. Saturday, sorry. I have written wrong. Friday, Saturday. Sorry. Yeah. So Friday, it was week 1 to 4.
Sir, so fifth was 5 to 8, week 5 to 8, and fourth was week 1 to 4.
Fourth means?
Sir, like 4th April was week 1 to 4, and 5th
Friday. Yeah.
yes, sir.
Saturday, 5th April was 5 to 8, and today we are
Sir,
discussing 8.
there also it was like full only PYQs only, no, sir.
Yeah, but we have discussed few initial concept also initially. Then we have discussed previous year question
Yes,
based
sir.
on the week 5 to 8.
Yes, sir. Thank you, sir.
Yeah. So this is what this procedure is doing here, right? It will always return true only for prime numbers. Now what we are doing here? Now this question is discussed above. What will the value of m? Now this question is based on the recursion part. Now what is recursion? We are calling the function. Okay, here we are not using the function. Okay, so anyway, this is not the recursion question, but we'll discuss that question. No worries. Let me check any recursion question is there. Do something. Yeah, this is the recursion question. I will come back to this question number 6. Let's quickly discuss this question also. Yeah. So here we have a m value of m at the end of execution. The procedure already discussed in the previous question. Okay, do something. So L is given to us. M is what? Empty list. Position equals to 1. For each element in else, for every element in else. So for the first iteration, element will be a 8. Do something 8 and do something element again 8 here. So sorry, position, right? So position is 1 here and element is 8 here. So we know when this do something will return true for prime numbers only, right? This is what we have discussed. What about this? When input is 1, what is the output for this do something 1?
False.
False, you can see here, right? And what about 8? For 8 also that will be false. So it is false and false. Anyway, entire condition is false. We are not going to do anything here. Position will be increment to 2 here. Go back to each element. Again, we are checking for second element here, right? So second position element will be 12. What about this particular case?
Again returns false.
2, 12, still it will return false. Now it is 3. Go to a next here. This will be 3. This will be 13. Now tell me.
This returns true.
Because for 13 we already discussed, it will return true. What about 3?
False.
For 3 also that will return true, na? 3 is also a prime number, na?
Prime number.
Yes, sir.
Oh, yes,
Position
yes,
number
yes,
is
yes.
also 3. This is
Okay.
True,
right.
true is
Yes,
correct.
yes.
Entire condition is true. Then we are going to append m. So m is initially empty. Plus element is what? Element is 13. Then we are going to add 13 here. So m will be 13. Position will be 4. Go for next iteration here. Now tell me. If I go back,
Now for
4.
every other element, it will be false.
No, here
Yeah.
it will be false.
Position number would be false.
Yeah.
And for every position, it will be false, and anyway, it will be false, irrespective
What
of the
about
number.
5? No, what about 5?
Uh,
5 would be true.
Element will be
increment
what?
the m element.
11, na?
0.
It will be true.
Oh,
These both condition become
yeah.
true, position and element.
So we are going to add 11 also. So that will be 13 comma 11. Then 6 position will be a 6 and here element will be a
False.
40. False.
False.
That's it.
False.
So here
13
position
element.
7, we don't have any element, we'll exit. Answer will be 13 and 11. Okay, like that. So here we are checking the position should be a prime number as well as element should be a prime number, right?
Yeah.
So instead of
Yes, sir.
giving the options, if I say, okay, so the m will consist of element having the prime number position, right? Also, element is also prime number, right? In that case, you might, in that case only, we are going to store the element in the list m. Okay.
You people are gonna change the options.
Yeah, in the sentence format also there can be a question, right? So when
Okay.
at what condition
Okay.
the element will get added in the m, right? So position is prime number, position is even, element is prime number, position is odd, element is odd, like that. Okay.
Now, what
Okay.
is the NAT written instead of MCQ in previous question or some other question?
NAT is numerical answer type. So you will not get
Okay,
options. You need to enter the answer.
Okay, got it. Thank
Yeah.
you.
So this is what we have discussed, question number 10 and 11. Now, I hope this thing is clear. Anyone, any doubt here? I want to discuss recursion question. Okay, here. So you can see here recursion question, because how it is recursion? We are defining a procedure here, and again we are calling the procedure inside the procedure only. Right? This is what recursion is. Calling a function inside the function only. Right? So how to solve this type of questions? Let's discuss, because this will take time if we give, let's say, 5 6 element. Here we just have 3 element, that is fine. Okay. So let's see. We have L1, L2. Okay. So we are calling a function do something L1 comma L2. Okay. So we are calling a procedure here L2 comma L1. Okay. So first for both the case we need to call the functions here, right? So let's say for this particular case we are going to discuss L1 and L2. Now what we are checking here, if length of x is greater than length of y, so x is L1, y is L2. Length means what? Number of elements. So do we have number of elements is not equals to number of element in L2? Is this
No,
condition true?
no,
No. So this is not true. We are not going to return 0. Go for this condition. Length is 1. Length is 1.
no.
No,
Return
because here
No,
we have
sir,
3
length becomes
elements.
3.
Now what we have to return? What is this? First of x. What is first of x?
1.
Yeah. So first
1.
element of the list L1. That is basically a 1. This is into. What is last of y? Last element of list L2.
2, 2.
2. Plus do something rest of x init of y. Now what is rest and what is init of y here?
Rest would be
Remove
minus
the first
5.
element in L1.
Rest will be a what? It will return the all the element except the first element. It will return all the initial element except the last element, right? So rest of
Remove the
x,
last element.
yes, rest of x will be a what? Minus 1, 5, and init of y will be what? 3, comma 1, right? Hello, right?
Yes, yes.
Yes,
Now
sir, right.
again we are calling this procedure for this input now. Now solve this question again for this one.
Minus 1 times do something of 5 and 3.
So whenever you see this recursion problem, na, always try to write down like this. Okay. So here we are going to write it down. So for this input, again, length is not 0, length is not 1. Again, we are going to do first of x, that is minus 1 into what? Last of y, that is 1, right? Plus, again, do something, again, rest of x. What is rest of x?
5.
5 only.
5 only.
And what is init of y? 3 only, right? Now for this function, again, we are calling here length is not 0. What about length equals to 1?
And that will be implemented. So
Yeah, if this is correct, then we are going to return first of x, first of y. So this is going to return 5 into 3. Now 5 into 3 is 15. So 1 into 1 minus 1 into 1 is minus 1 plus 15. That will be 14, right? Answer of this will be a 14 plus 2, that will be a 16. So here answer will be 16 for this particular scenario. Okay. Now this is what for this function 16. Same thing we have to do for L2, L1. Now what will happen in the case of L2, L1? Okay, first tell
it's
me,
reversed.
do you understand what we have done here? How this procedure is working?
Yes, sir.
Yes.
Yeah. So always write down like this whenever you see recursion problem. Now we are going to call that function. Just create this tree type of structure and then you can easily add or whatever the operations we have to perform, we can do. Otherwise, you will get confused, right? So this approach you can follow. So we have done for this one. What about this L2, L1? What will be the value? Just tell me.
Be again 16.
Again 16 get. Sir, get again 16.
Again 16 because anyway length is not different. Here what we are going to do. If even if I change the sequence, first of x, last of y, so that will be what? 3 into 5, 15. Plus again we are doing this 1 minus 1, 1, 2. So again if you follow the process, again you are going to get 16 as an answer. 16 minus 16 will be 0. Okay. So do solve this question. It's not like that. Again, if we give again 16 will come, right? There might be some changes here in the code. So that will give a different answer for L2, L1, right? So do solve the questions. Okay. So in this way, how this recursion is working. So always try to write down like this manner, like what we have done. Okay. Go in a tree format. So it will be easier to collect the output and then return the output. Okay. Okay. Any question now? Anyone? So here you can see any type of question, you need to enter the value here like that. Okay, so we have discussed graph and recursion based questions. So please try to solve. This is the only important in week 8 to 11. All PA plus GA plus whatever the question we have discussed, this 7, 8 questions, 6, 8, whatever the question we have discussed. If this is enough for week 8 to 11, okay. So PA very important, GA very important, and whatever the question we have discussed. So try to solve PA and GA.
Hello.
If you have not solved, you can ask any doubt if you have in the next session as well. Yes.
So week uh, week 9 last
Sorry, I'm not
graded
able to
question
hear.
last number, sir.
Last number what? Can
Week
you repeat it?
week 9 graded question, graded
Okay.
assignment.
Okay. So you have doubt in week 9 grade assignment. Okay. So anyway, any doubt what we have discussed up till now? I will take that question then. Okay. Great. So please try to solve all the assignment questions from week 8 to 12. Okay. Which question you said? Week 9, question number, last one.
Sir, now we discussed this,
Yeah.
which period, sir, this one, what we discussed?
Previous year question, previous term questions.
Can I know the period? So we can access the from
No, from initial only, we have started the discussion. Okay. After 5 minutes only.
no, sir. What I'm asking, which period this question actually? So PV, so I can select from for the practice.
It's
Which term
which
PYQ?
term? Okay. Okay.
Yes.
It's May term, May 24.
Okay. Thank you.
Yeah. Okay. So
Hello, sir. Excuse me.
yes.
Sir, for end term, like we'll have more portions from week 9 to 11, and then week 1 to 4 and week 4 to 8 will be equally split out, sir.
Not like that. Every week is having equal importance. So you can see around, yeah. So there will be 20 questions will be there. Out of 20 questions, you can expect 5, 6 questions from the week 9 to 11. Okay. So yeah, almost you can say 40% weightage.
Sir, so it's equal, like all weeks are equally split out.
Yeah. So week 9 to 11 will have little more weightage. So you can say week 1 to 8 will be around 60%. Week 8 to 12, sorry, 9 to 11 will be around 40% like that.
Sir, so the important topics in week 9 to 11 are those adjacency matrix and those DFS. Only like these two are the most important things, no, sir?
Recursion, adjacency matrix, yes.
Yes, like even including recursion also.
And please solve PA and GA also. Okay.
Yes.
Okay. So let me discuss this question.
Sir, how to calculate interim marks?
How to calculate interim marks?
Uh, Means, sir, quiz 1, quiz 2, and graded assignment uh, average score, it would be included in this mark.
Yes. So there is a grading formula. You can see a grading document on the portal. So in that you can see a formula for every course. In CT also we have some formula. Accordingly, you will get the grade in your course. So you can just go to instructions initially. We have a grading document there. In that grading document, we have a formula. According to that, you are going to get the grade. Okay.
Okay, sir.
General instructions, and then you can see the grading document. So if you see the grading document, let me check. CT, yeah. So here we have 10% weightage to grade assignment. Then we have, you can check that formula, 60% to a final exam, end term exam, plus 20% of maximum of quiz 1, quiz 2, or we have 40% of that one. So whatever the maximum you get, we'll take that one only. Okay. So you can check that particular formula in the grading document. Okay, great. So question number 9. Sorry, who asked that question? Basant, right?
Yeah.
Week 9, which question?
Last, I am not getting able to get the question.
Last question. This one?
Yeah. La this related to previous one. Yeah.
Okay, this one, na?
Yes, yes.
Okay. So here, we need to go through this. Computer scientist planning to an event in city. She has come up with a novel scheme, invite people. So how she is going to invite the people? See here, host can send any number of invitation, does not accept any invitation. Okay. Host can send out any number of invitation and does not accept any invitation. Okay. So how we can invite? It can send any number of invitation, but not accept any invitation. Okay. Each invitation is represented by a unique text message. Each invitee can choose to either accept or reject invitation. Okay. If invitee accept the invitation, then he can invite exactly one other person by forwarding the invitation that he received to this person, right? So invitee can forward the message he received only once. Okay. Accept the invitation. So in terms of, let's say I is the host here, J is basically invitee. So if I invite J and J accept, only then J can invite Z. Okay. Is that
Yes.
okay?
Yes.
So I is basically host. Host send the invitation to J. J accept, then only he can invite to J. Z. Otherwise, he cannot invite if he didn't accept. Right. This is what this point is saying. Okay. Then we have if an invitee doesn't accept the invitation, he cannot invite. Yes. If a person receives multiple invitation, he can accept at most one of them. All other must be rejected. If I say multiple invitations like this, so only one will be accepted. It can reject a remaining one, right? It means what? Doesn't matter how many invitation that J will get. J can always invite only one person, right? Hello?
Accept.
Yeah.
Yes.
The
Yes. Yes.
situation is modeled as graph. There is a node corresponding to every person who attend the event. N people attend the event. Okay. Attendees are indexed from 0 to n minus 1. Given a pair of attendees I, J, there is an age from I to J. Okay, if and only if. So very important. So whenever you see this graph kind of question, na, always check when we have defined the age. So I is J, I to J will be an age when J was invited by I, yes, or J accepted I invitation. Okay. So if only
Yes.
following conditions are satisfied, you can see J accepted I's invitation, yes, or J was invited by I. In that case only there will be an age. Okay. Now, the graph is represented by a matrix A such that Aij equals to 1 if and only if there is an age from I to J, okay? For case of n equals to 5. So, let's say we have 5 people. So, the following possible representation of a graph. What about the first one? Is this possible?
No.
Why no?
0 accept multiple invitation.
How we can say?
In question, anyone can accept only one invitation.
Yeah, if 0 receives multiple invitation, he can accept only one invitation. This is what we are saying, right? So you can see this 3 doesn't have any inward arrow, right? He is only
Oh,
sending the invitation. It means what? Yes, anyone?
host 3
Yes.
is host.
3 is host, right? Now 3 is inviting 4. If 4 accept, 4 is inviting 0, right?
Yes.
Then what about 3? If 3 invites 0, then 0 will invite 1, right?
Yes.
Then how this 2 will get invite? There is no way that 2 will get invitation, right? So what we have said, I send to J, J if accepted, J only invite only one person. That's it. Right? We can see
Yes.
here e- exactly one person by forwarding invitation and the invite can forward receive only once. Right? Yeah. You can see the message is received only once. Right? So this is not possible because two anyway, no one can invite two. Three is a host inviting zero, zero can invite one. So we can reach till one here only, not two. What about B? Which one is host here? Zero or three? Yes, anyone? Let's say for zero as a host. Now zero is inviting one, one accepted, one is inviting two. Okay, so we can reach here. If zero is inviting one can invite four. Yes, that is also fine. But either one can invite two or four only, na? He cannot
Yes.
invite both, right? So anyway, this is not correct. What about C? 3 is a host here. 3 is inviting 4, correct. 3 is inviting 0, yes, correct. 0 is inviting 1, yes, that is also correct. 1 is inviting 2, invitee accept the invitation, then he can exactly invite only one other person by forwarding the invitation that he received to this person. So invite can forward a message he received only once.
Sir, I have
Okay.
a doubt in the first option. So
Yeah, yeah.
by this third statement, so this one should have been correct, right? Because
Yeah.
one can pass the invitation to two.
One can pass the invitation to two, but yeah.
That's possible.
But here we have seen, okay, yeah, this is possible. But what about this one? 3 is a host, 3 is inviting 0. So 0 to 1, okay, 1 to 2, that is fine. But 3 is inviting to 4, and 4 is also inviting to 0,
Okay, so
right?
zero cannot invite, you can accept at most one.
At most 1, yeah. This should not be there. So I think this question violating which condition? Yeah, he can accept at most one of them. All
Yep.
other must be rejected, yeah.
Yeah.
But here, that's not the case in the option number C, right? It is not like that. So
Yeah,
here,
this one is fine.
yeah, 4 is not inviting anyone. That is fine. 0, 0 to 1, 1 to 2. That's why option C is correct. What about a D? Let's see, 0 is not a host, right? Because he is getting an inward arrow. Who is host here?
Seems no one is a host. So
No one is
D,
a host. So party cancel, right? So no one is a host here because 3 is inviting 0, 0 is inviting 1, 2. No, this is not a correct one. So C is the correct one here. Option D, there is no host, correct. Option C, no 3 hosts is invited 0, okay. No 3 hosts not receiving any invitation and is inviting more than one people. Okay. When we traverse the graph, we can see node 0 is accepting more than one. Yes, that's the same reasoning video. Yeah. So option C is correct. Is that okay, Basant? Any
Yeah.
doubt?
But this explanation not given my dashboard, sir. How can accept access this solution
No, it is given, na?
explanation?
Let me check the portal.
Uh, I am
No,
not checking, sir. I
no, you can
check.
see grade assignment 9. Below that, we have a grade assignment 9 solution. So inside the week
Okay.
unit only, you can see the solution. Okay.
I
We'll release for week 11 also. I think for week 11, it is not released. We'll do that. For week 9, it is there. And for week 10, let me check. For week 10 and 11, I will release it now only. Okay. Yeah.
For
Okay.
practice question, this solution not available.
Practice assignment also
Explanation.
not available.
This type of explanation.
So solutions are not available, you are saying?
Yeah.
Okay. Your voice is breaking. I am not able. Is it for me only or for everyone?
In practice examined this type of solution, I
Okay.
am not get.
Yeah, yeah. So I will release the
So I
solution. Don't worry. Yeah. Okay. Any other doubt, anyone? Just after session, I will release all the solutions. Yeah. So please go through the assignment questions, very, very important, and then previous year question. Okay. So you can solve the questions, you can practice. So that will be enough for end term exam. Okay, then that's it from my side. If you have any question, you can ask.
Thank you, sir.
Okay, thank you.
Thank you, sir.
thank you, sir.
Thank you.
Thank you. Bye bye.